This is a key to rational expressions extra number 4. And notice you had two problems in this one. You had these two rational expressions that you were adding together, and then these that you were subtracting. And remember, it does say show all work to receive any credit and state the LCD as well, and then circle your answer. So in number 1, I'm going to go ahead and rewrite number 1. You have 4 divided by x squared minus 12x plus 32. And then you're adding this rational expression to this one, 6 rather, divided by x squared minus 2x minus 8. All right, now remember, to add two rational expressions, you have to have the same denominator. But notice, though, that these are polynomial expressions. So you want to factor first. So the first thing you got to do is factor the denominators. So when I factor this denominator right here, and then the same thing here, I'm going to get, for this one, I'm going to get x minus 8 times x minus 4. Okay? And that's going to give me this trinomial. Over here, when I factor this, I'm going to get x minus 4 times x plus 2. Now, I'm going to go ahead and rewrite this over. Now, I'm going to rewrite it like this. I'm going to go ahead and say 4 divided by x minus 8, x minus 4, plus 6 divided by x minus 4, x plus 2. All right, so that's the next thing you want to do. So you want to go from here to here. Now, once you get to this point, you now have to find the least common denominator because you cannot add these yet. You cannot put this as one rational expression because the denominators are not the same. See, they look totally different. So remember, the least common denominator must include every factor you see. So I see an x minus 8, I have to use it. So it has to be part of my LCD. I see an x minus 4, it has to be part of my LCD. I see an x minus 4, I already have it. I see an x plus 2, I don't see it, it's got to be part of my LCD. So notice that the least common denominator is made up of those three factors. And leave your least common denominator in factored form. Don't multiply this out. Especially these three binomials, you could easily make a mistake. Leave it in factored form. It must be left in factored form. Leave it in factored form will get you through the process. Okay, now we're going to write equivalent fractions using that denominator. So I'm going to go ahead and rewrite this over, but I'm going to leave some space between these two. So in other words, I'm going to say 4 divided by x minus 8 times x minus 4. Leave some space here. Plus 6 divided by x minus 4, x plus 2. Okay? All right, now I'm going to write two equivalent expressions using this denominator, using the LCD. So I'm going to do this. Notice I'm doing this. I'm going to rewrite. I wrote this and then put the denominator, the LCD next. X minus 8, x minus 4, x plus 2. X minus 8, x minus 4, x plus 2. Okay, now notice that I want to write an equivalent rational expression that's equivalent to this with this denominator though. So this has two factors, this has three. So I'm missing, see, you have the x minus 8, you have the x minus 4, you're missing the x plus 2, right? So you got to say times x plus 2 times x plus 2. So if I put that in a colored pen, I guess I should have done that to make it more visual. So you have x plus 2 here, okay? And so now this becomes the numerator then becomes, okay, so I'm not sure if you're able to see this color. Hopefully you will. So this denominator now becomes this. So it becomes 4 times x plus 2. So that's purple. I guess you really can't tell the difference. And we're going to do the same thing here. So if you notice that I have the x minus 4s, right? See it? And then I have the x plus 2s. So what I'm missing is the x minus 8. So if you think about it, what you may want to do is kind of highlight, if you need to. Let me just quickly see if I can find a highlighter. Okay, I can't. So you're basically going to notice that I have the x plus minus 4s, I have the x plus 2, so I'm missing the x minus 8. So you can say times x minus 8 and then times x minus 8. So this numerator here is going to be 6 times x minus 8, just like this. Okay? And then notice you can always determine that you're doing this correctly because if you reduce the x plus 2's here, if you reduce it, see this right here is what you had right here. Okay? If you reduce the x minus 8's here, see the x minus 8's, then you have 6 divided by x minus 4x plus 2, which is what this was. Okay? Okay, now the next step is to write this as one rational expression. One rational expression since the denominators are now the same. Just like this. Okay, now you're going to put the two numerators here. But to do that, let's go ahead and distribute the 4 and distribute the 6. So if I distribute the 4 and the 6, I'm going to get 4x plus 8. See, 4 times 2 is 8. So 4x plus 8 plus, see, that's an addition symbol, so that's going to be the easy kind. 6x minus, and then 8 times 6 is 48. So 6x minus 48. Okay? Okay, now, combining like terms, I get 4x plus 6x is 10x. 8 and a negative 48 is a negative 40, divided by x minus 8, x minus 4, x plus 2. Okay? Now, at this point, again, don't multiply this out. You multiply this out, you're missing the point. So remember, the whole idea is to make sure that your rational expression is simplified. Well, to determine if it's simplified, you got to factor everything, the numerator and the denominators, and then reduce. So the denominator is already factored. The numerator is not, because I can factor out a 10. So when I factor out a 10, I get 10 times x minus 4 divided by x minus 8, x minus 4, x plus 2. And now you'll notice that the x minus 4's divide out, and you get 10 divided by x minus 8 times x plus 2. And that's your answer. Okay? So there's your work. That was your work, and there's the answer. Okay, that was number 1. Let's look at number 2. In number 2, we have, now this is going to be a subtraction problem for number 2. So number 2, we have 10 divided by x squared minus 8x plus 15. Subtract 5 divided by x squared minus 7x plus 12. Okay? So before we find the LCD, or before we even attempt to subtract these rational expressions, the denominators must be the same. So notice though, I have to factor those denominators. So when I factor those denominators, let's see, this is going to be x minus 5, x minus 3, and this you can factor as x minus 3 times x minus 4. So your least common denominator, remember, must include every factor that you see. So I see an x minus 5, I need it. I see an x minus 3, I need it. I see an x minus 3, I already have it. I see an x minus 4, I need it. So in number 2, your least common denominator is made up of these 3 factors. Don't multiply that out. Leave that as in factored form. So now what we're going to do is I'm going to rewrite this rational expression with the denominator that's factored. And so I get 10 divided by x minus 5, x minus 3, minus 5 divided by x minus 3, x minus 4. Okay? Okay, now I'm going to write equivalent fractions, but before I do that, I'm going to rewrite this, leaving some space. So I get 10 divided by x minus 5, x minus 3, leave some space, subtract 5 divided by x minus 3, x minus 4. So I'm going to write, now remember, I want to be able to add these 2 rational expressions. I cannot do that just yet because the denominators are not the same. So I get them to be the same, and that's that LCD I'm going to need. So I'm going to write 2 rational expressions, 2 equivalent expressions with this denominator. Just like this. Okay, now, all right, so now here's what you got to do. You got to remember to do this. So notice I have x minus 5, x minus 3, and I'm missing the x minus 4, the factor x minus 4. So I got to put it here. So what I do to the numerator, to the denominator, I must do to the numerator. See that? All right, and let me go ahead and make it darker. I'm going to use a different color. So x minus 4, x minus 4. And so now I'm going to rewrite this here. So that's 10 times x minus 4. Okay? Over here, same thing. I have the x minus 3, I have the x minus 4, I'm missing the x minus 5. So I'm going to say times x minus 5 times x minus 5. What you do to the denominator, you do to the numerator. And so now this goes here. So 5 times x minus 5. Now you know, you always know you're doing this correctly. If you were to reduce, see how I can reduce the x minus 4s here? What's left is what you have here. And then if I reduce the x minus 5 like this, I get 5 divided by these two factors, which is what this is. So this is equivalent to this, and this is equivalent to this. So now what you're going to do is you're going to write this as one rational expression since the denominators are the same. So just do this for right now, x minus 5, x minus 3, x minus 4. All right, now we're going to distribute. Now you got to be careful with this one. Now this one's easy to distribute because that's a positive 10. 10 times x, 10 times negative 4. So that's 10x minus 40. Be careful here. Remember what you want to do is you want to rewrite this as an addition problem. So you want to say, and I'll go ahead and rewrite it here. So I'm going to say add the opposite, right? Add the opposite. So it'll be plus a negative 5 times x minus 5. So just do that for right now. So I just rewrote this little part here. And now distribute the negative 5. I get 10x minus 40. A negative 5 times x is negative 5x. A negative 5 times a negative 5 is a positive 25. Divided by, and leave this in factored form. Leave it in factored form. If you multiply that out, you're not going to see that it's reducible. 10x minus 5x is 5x. A negative 40 and a positive 25 is a negative 15. Divided by x minus 5, x minus 3, x minus 4. Now, remember, you got to see if you can reduce this. So I can factor out the numerator. I can factor the numerator. I can factor out a 5. So you had 5 times x minus 3 divided by x minus 5, x minus 3, x minus 4. And notice the x minus 3s, the factors of x minus 3s divide out. And so you get 5 divided by x minus 5, x minus 4. And there's your answer. Okay? So that is the key. That is the key to the worksheet extra number 4.